So let's go ahead. Yeah. So good afternoon once again, students. So today we are going to concentrate on the thermodynamics lesson, problem solving. Okay, the previous year's questions, problem solving we are going to do in today's session. All right. So the topics that I'm going to discuss, or the topic that we are going to cover in today's question session, is the basics in thermodynamics, the first law of thermodynamics, thermochemistry, and spontaneity. Okay. So from these topics, we are going to cover the problems in today's session. All right. So I hope you all have your notebook and pen with you. Am I right? If you do not have those things with you, please try to have it with you so that you can start solving the questions. Thermodynamics lesson is a physical chemistry lesson, right? Yeah, it is a physical chemistry lesson, right? So we have to solve numericals. More number of numericals will be there here in the lesson. Got it? Shall we start? Are you all ready? Good afternoon, Manu. Are you all ready? Okay, fine. So let's go for the first question for today's session. And here is a question on your screen. And the question says that when delta H vaporization is equal to 30 kilojoule per mole and delta S vaporization is equal to 75 joule per mole per Kelvin, then the temperature of vapor at 1 atmosphere is dash Kelvin. So how to approach this? This is a question from JEE Mains this year, right? And delta H and delta S is given. So how to find out the temperature? So can anyone give me the relation or the formula that we have to use here to solve this question? Can anyone tell me the formula in the chat box? Give me the formula in the chat box. So do you guys remember the formula that has to be applied? Do any of you wants to give a try for it? Okay, I will go ahead. So to find out the temperature, the formula that we have to apply is delta H of vaporization divided by delta S of vaporization. That's it. Okay. Direct substitution. We have both the values in the question. Just you substitute directly. But before substituting, you need to look into the units. Delta H is given in terms of kilojoule and delta S is given in terms of joule. So what we have to do, we have to convert the kilojoule to joule. Okay. So kilojoule means it is 30 into 10 to the power 3 joule. Right. Divided by delta S is 75 joule. So what is 10 to the power 3? It is 1000. So it is 30,000 divided by 75. So if you solve this, what will you get? So 30,000 divided by 75 is 400 Kelvin. Okay. 30,000 divided by 75 is 400 Kelvin. So the temperature of vapor at 1 atmosphere is 400 Kelvin. Okay. So this is how you have to solve. Such an easy question, right? Can you all able to understand? Can you all able to understand? Do you have any doubts? Shall we go for the next? Shall we solve the next question? Give me your answers in the chat box. Give me your answers in the chat box. Yes. Maralakshmi is saying yes. What about others? Did you guys solve? Yes. Okay, let's go for the next question. The delta H vaporization of water is plus, yes, Kausalya, it is exactly 40 Kelvin. Your answer is correct. Very good. So let's go ahead with the next question, okay? Delta H vaporization for water is concepts of this chapter is not clear. Manu, we have already dealt with this chapter in the last week in Enable Plus session. Have you attended the classes of Enable Plus in your school? No. So that's why you feel little bit difficult. But from this question onwards, I will try. Okay, I will try to explain you the concept also. So in the previous question, if you have seen, there is nothing to deal with the concept. Okay, it is just the formula substitution only. Just I have taken the formula which has to be applied over there and which we have learned in that particular topic. So I have just taken that formula and substituted all the given values. Okay, so nothing to worry about the theoretical part in the previous question. Okay, so if you do not understand this, the concepts of this chapter, please go through the formulas that you have in this chapter from your school notes or by seeing the lectures which is there in the YouTube in Avanti Live 2 channel. Okay, from Enable Plus. So there you can get the formulas and the concepts which I have taught. If you are also having in your school notes, then it is also fine. Okay, so please go through the formulas which is there and try to understand. Is that okay? Is that okay? Since this is a physical chemistry lesson, mostly we will be taking the formulas which we have learned and we will substitute all the values. Okay, clear? For organic and inorganic only, we will be using more conceptual thing kind of. Got it? Okay, fine. So now coming to this, delta H vaporization for water is given at 1 bar pressure and 100 degrees Celsius. Change in internal energy for this vaporization. So delta H value is given, okay, and pressure value is given. 100 degrees Celsius means it is temperature, right? Temperature is given. Then internal energy is asked, okay, under the same condition as dash kilojoule per mole. Internal energy means it is U. Change in internal energy means it is delta U. Okay, so we have to find out the delta U for this reaction. So how to find out the delta U? There are one formula. There are two formulas to find out the delta U from first law of thermodynamics. That is different. Okay. So the two formulas are delta U is equal to Q plus W and delta U is equal to NCV delta T. So these are the two formulas which will be used to find out the delta U. But we are not going to use either of any of these two formulas here. You know why? Delta H information is given to us in the question. So which formula has to be applied? We have studied one relation between delta U and delta H. Okay? We have studied one relationship between delta U and delta H. And the relation is delta H is equal to delta U plus delta NG RT. Okay? So this is that relationship. Here in this question, we are dealing with 1 mole of water. We are dealing with the 1 mole of water. Since the reaction conditions are standard here, we are dealing with 1 mole of water. So the number of moles of water becomes 1. So this delta Ng, which is the number of moles, it will become 1. So this term will become 1. Okay. So then the formula will be delta H is equal to delta U plus RT. That's all. Okay. So what do we need to get from here? We need delta U. So what I'm going to do, I'm going to keep delta U one side and I'm going to take plus RT to the other side and it will be written as minus RT. Okay. So now you substitute the values. What is the value of delta H given in the question? It is 40.79 kilojoule. Kilojoule means you have to represent the answer in terms of kilojoule only, but the R value is given in terms of joule. We cannot change the R value, right? But we can change the delta H. So multiply this by 10 power 3. So it will be 40, 40790, right? 40790, because it is 40.79 into 10 to the power 3, right? Into 1000. So 1, 2, 3. So you have to move the decimal to 3 digits towards right side. So you will get 40,790 minus R value is 8.3 into the temperature given is 100 degrees Celsius. But we have to give in terms of Kelvin, right? So to convert the Celsius to Kelvin, what we have to do? 100 plus 273. 100 plus 273.15. So if you add 273.15, you will get the answer in terms of Kelvin. So it will be 373.15. So this is the value for temperature. So substitute that. 373.15. Okay. I hope everything is clear up to this. I hope everything is clear up to this. Okay. If you are getting any doubts in between, please feel free to ask. Okay. Don't get scared or don't feel shy to ask your doubt. So now after this, there is just multiplication and subtraction concept or part only. So if I multiply 373.15 with 8.3, I will have 40790 minus 3097.145. Okay. Then if I subtract this number from 40,790, I will get 37,692.855 joule per mole. This is the value of delta U in terms of joule per mole. But we have to give the integer answer in terms of kilojoule per mole. Okay, so to convert joule to kilojoule, what I have to do? I have to move the decimal to left side to 3 decimal. Okay, so I have to move it to 3 places. So I will get 37.692 kilojoule per mole. Okay, but still the answer is in decimal. We have to give the answer with integer, right? So just you round off this. So after this point, I have 6. So it will be 38. Very good, Rakshita. Very good. Exactly correct. So if I round this off, what will I get? The approximate answer will be 38 kilojoule per mole. 38 kilojoule per mole. So the answer is 38. Okay. Is it clear for all of you? Do you have any doubts? So what we have done, what I have did here. So I have used the relationship between delta H and delta U. Okay. Then since we are dealing with 1 mole of water, the number of moles is taken as 1. And the remaining values are substituted in the formula. And the only one thing that you have to concentrate is the unit. Okay. So initially I have did the entire thing with joule per mole because the R value is given in terms of joule per mole. Then later on, since they have asked the answer in the question in terms of kilojoule per mole, I have again converted it. Okay. So if you want to convert kilojoule to joule, then you have to move the decimal to right side. Okay. And if you want to convert joule to kilojoule, then you have to move the decimal to left side. So this is the only point you have to keep in mind. Okay. Because if you make, this is a very simple point. Okay. Very small point. But if you make any mistake here, you will end up with the wrong answer. Okay. So just have a note of some simple and small things like this carefully. Okay. So do you have any doubts in this question? Did you all get to know how to solve this type of question? Shall we go for the next? Shall we go for the next question? Say yes or no. Yes? Okay, okay, dear students. I'll go for the next. Yeah, again, the JEE mains question. So first I'll solve a set of JEE main question, then we will go for the NEET questions, okay? So there is a figure provided to us. 1 mole of an ideal gas is kept in a cylinder fitted with a piston. So we have 1 mole of an ideal gas inside this at a position A at 18 degrees Celsius. If the piston is moved to position B, okay, if the piston is moved to position B, piston means the object which is used to give pressure. Okay, if it is moved from piston A to, if it moves from position A to position B, keeping the temperature unchanged, then X liter atmospheric pressure work is done in this reversible process. What is the value of X in terms of liter atmosphere? And the absolute temperature value is given, R value is given. So how to approach this question? We are ultimately have to find out the work, right? Work done in the reversible process. To find out the work done, it is equal to minus 2.303 into nRT into log of V2 divided by V1. So this is the formula to find out the work done for reversible process, right? So I have given you 3 formulas to find out the work done, and this is for reversible, and the other one is for irreversible, and the third one is for free expansion. All right. Now you substitute all the values. So we have minus 2.3 as a constant into number of moles. What is the number of moles here? 1 mole. So the number of mole is equal to 1. And what is the R value? It is 0.08206. Okay. Into temperature. So temperature is 18 degrees Celsius. But we have to represent it in terms of Kelvin, right? So to convert that, 18 plus 273.15 we have to do. 273.15. So the answer will be, so the temperature value will be, the answer is, what is the answer? 273.15 plus 18. So it will be 291.15. 291.15 into log of V2. V2 means final volume. Okay, final volume is 10. Final volume is V2 value will be 10 liter, and V1 initially we would have had 100 liter. Okay, initially we would have had 100 liter, but the final is 10 liter. Got it? So V2 value is 10 and V1 value is 100. So if I cancel this and if I take this 10 to the numerator, I will have log of 10 to the power minus 1. I will have log of 10 to the power minus 1. So the answer for log of 10 to the power minus 1 is equal to minus 1 because log 10 is 1, right? So it will be minus 1. I hope all of you know how to do it. So it is log of m to the power n format. Okay, the formula will be n into log of m. Okay, and here we have log of 10 to the power minus 1. So it is minus 1 into log of 10. Log 10 is equal to 1. 1 into minus 1 is minus 1. So the entire value is minus 1. So minus 1 into 291.15 into R value into 1 into 2.303. So if you multiply all these values, you will end up with 55 liter atmosphere. Okay, as a value for work done. 55 liter atmosphere as the value for this question. Okay, so the answer will be 55 liter. All right. Can you all able to understand? So just only one formula which we have studied to find out the work done. So that is being used. The another thing is you need to do the multiplication very fast, okay, to get the answer. And you need to know to find out the given values. So number of moles is 1 and this is the temperature and this is the volume. So like that you need to find out. Okay. Clear for all of you? Any doubt? Any doubt? Shall we go for the next question? Shall we go for the next question? Yes or no? Okay. So coming to the next. The heat of combustion of solid benzoic acid at constant volume is minus 321.30 kilojoule at 27 degrees Celsius. The heat of combustion at constant pressure is the value of X. So, listen. The heat of combustion of solid benzoic acid. What is meant by combustion? Heating a compound in presence of oxygen. And here the compound is benzoic acid. So the formula for benzoic acid is C6H5COOH. And COOH, if it is treated with O2. O2 means 15 by 2 moles of O2 will react with this. Okay. So, and it will give 7 moles of carbon dioxide and 3 moles of water. 7 moles of carbon dioxide and 3 moles of water. Okay. So, this is the complete combustion reaction for benzoic acid. Okay. So, you might have studied how to get this reaction in your class 11 hydrocarbons lesson. Okay, so you will get to know how to take out this reaction when hydrocarbons lesson is being taught to you. Okay, so don't worry about the reaction. Don't think like, ma'am, how will I get to know that this is the reaction for complete combustion? Don't think those things. So they will, I will teach you, okay, how to find out. Got it? For complete combustion. So in complete combustion, carbon dioxide and water will come out, and that is what I have written here. Okay, don't worry about the reaction. Now we have to find out the value of X. X is given here. Okay. So, what else is given to us? The heat of combustion is given. Heat of combustion means delta H value is given. Okay. Delta H value is given to us. Delta H value is given to us. And also the temperature. We also have the temperature value. Okay. We also have the temperature value. The heat of combustion at constant pressure. Heat of combustion at constant pressure is equal to delta H is equal to delta U plus delta Ng RT. So again, this formula you have to use. Okay, you have to use this formula because the heat of combustion at constant pressure means it is delta H, and let me take this heat of combustion as delta U. Okay, this is the heat of combustion at constant volume, right? Constant volume means it is delta U. Constant pressure means it is delta H. So we have to find out the heat of combustion at constant pressure delta H. So it is equal to minus 321.30 kilojoule plus delta Ng. What is delta Ng? Delta Ng is the number of moles of gaseous product minus number of moles of gaseous reactant. Okay. So how many products we have? 2 products. And what are their number of moles? 7 and 3. So 7 plus 3 is 10 minus. Here what we have? We have 2 reactants. Only one among it. Yeah, one among it is the oxygen and the other one is the benzoic acid. Okay. So if I substitute And if I get the answer, it will be 15 by 2 plus 1. 15 by 2 plus 1. And if I solve this, I will get 1 by 2. If I solve this, I will get 1 by 2. Okay. Now, substitute here as 1 by 2. Not 1 by 2, it is minus 1 by 2. It will be minus 1 by 2 as the answer. So, it should be minus here. Should be minus 1 by 2. And R value is not given. So, let me keep this as R. And temperature is given as 27 degrees Celsius. 27 means 27 plus 273. So, it will be 300 in terms of Kelvin, right? So, it is 300. It is 300. Got it? So, it will be, so this entire thing is actually XR. If you look here, this entire thing is XR and we have minus 321.30 here. Okay. So this entire thing is XR. So leave this R and if I cancel out this, I will get 150. Okay, I will get 150. So what is the value of X? Value of X is 150. So the final answer will be minus 321.30 minus 150 into R. So the X value is coming out to be 150. Okay. So the answer is 150 for this question. So is it clear for all of you? Do you have any doubt? Do you have any doubt? Is everything okay? Can you all able to understand? Okay. So let's go ahead with the next. The enthalpy of formation of ethane from ethylene by addition of hydrogen where the bond energies of CH, CC, C double bond C, HHR. So there are 4 values given for all the bond energy in the question. Okay, we have to find out the enthalpy of formation. So how to find out the enthalpy of formation from the bond energy? How to find out the enthalpy of formation from bond energy? So for that, you need to have the reaction first. So it is the formation of ethane from ethylene. Okay, we are going to prepare ethane, which is C2H6. C2H6. This is ethane. See, this ethane is produced from ethylene. Okay. So, ethylene means it is C2H4. C double bond C and H4. Okay. By the addition of hydrogen. H2. So, in H2 we will have HH. Okay. In H2 we will have HH bond. And this is ethylene. Got it? So, now to find out the delta HF, to find out the enthalpy of formation from the enthalpies of bond energy. It will be equal to summation of delta H of bond energy of the reactants minus summation of delta H of bond energy of the products. Okay, so this is the formula to find out. So now in the reactant, what we have? We have carbon-carbon double bond in the reactant. And its value is 615. Okay. And what we have? We have 4 carbon-hydrogen bond. We have 4 carbon-hydrogen bond. So carbon-hydrogen bond energy is 414. We have 4 CH bond. So it is 4 into 414. Okay. Then we also have one hydrogen-hydrogen bond and its value is 435 plus 435. So this is the summation of bond energies of the reactants. Okay. Next, coming to the product. In product, I have one CC bond and its value is 347 and I have 6 CH bond. So it will be 6 into 412. Okay. Now, if I solve this, I will get 2706 here in the reactant side and 2831 in the product side. Okay. The final answer will be minus 125 kilojoule. So the answer is minus 125 kilojoule. Clear? So to find out the enthalpy of formation from the bond energy, you need to do reactant minus product. You need to do reactant minus product. Since ethylene, hydrogen, ethane, all of them are gases, you just have to take all the bond values, bond energy values and substitute in the formula to get the answer. Clear? Able to understand? Can you all able to understand? Shall we go for the next? Shall we go for the next? Students, am I audible? Shall we go for the next question? Kausalya, Rakshita, Trisha, Varalakshmi, can you all able to hear my voice? Yeah. Okay, okay. So please note down this formula. Now we will go for the next. For a certain reaction at 300 Kelvin, K is equal to 10, then delta G naught for the same reaction is. Delta G naught for the same reaction is. So to find out the delta G, we have one formula, right? It is minus RT into ln K, right? So to convert this ln to log, we have to multiply by the number 2.303. So it is minus 2.303 into RT into log of K. Okay. So now find out the answer. Minus 2.303. What is the R value? It is 8.314 into the temperature. Temperature is given already in terms of Kelvin. So it is 300 Kelvin into log of K value is 10. So log of 10. So here log 10 is equal to 1. So if you multiply all these things, you will get minus 5744.1426 joule per mole as the answer. Joule per mole as the answer. But we have to give the answer in terms of kilojoule per mole and also with 10 to the power minus 1. So first let me convert this joule per mole to kilojoule per mole. So joule to kilojoule conversion has to be done by moving the decimal to left side. Okay. 3 digit to the left side. So it will be minus 5.744 into kilojoule per mole. Okay. So this is the delta G value in terms of kilojoule. But we have to give in terms of 10 to the power minus 1, right? So if I want to represent with 10 to the power minus 1 kilojoule per mole, then again I have to move this decimal to right side. 1 digit right. Okay, 1 place right. So delta G naught will be equal to minus 57.44 into 10 to the power minus 1. Okay, the answer is minus 57.4. Can you all able to understand? Just it is about the decimal thing. That's it. Remaining things are same only. Clear? Shall we go for the next? In all the questions, if you have noticed, We are using only one formula, and the important place has to be given to the units and the conversions only. Okay. So rest all is just the direct substitution into the formula. Can you able to understand, students? Do you have any doubt in this question? Shall I go for the next? Shall I go for the next question? Say yes or no. All right. So coming to the next question. If 5 moles of an ideal gas expands from 10 liter to a volume of 100 liter at 300 Kelvin under isothermal and reversible condition, then work is minus x joule. The value of x is. So what we have to do? We have to find out the work. Okay. And they have said that the process is reversible and isothermal. So the formula to find out the work done in reversible process is equal to minus 2.303 into nRT into log of V2 by V1, right? This is the formula to find out the work done for reversible case. So it will be equal to minus 2.303 into number of moles. So how many number of moles we have? We have 5. Number of mole is 5. And what is the R value? It is 8.314. And what is the temperature given in the question? It is 300 Kelvin. Okay. And what is the log value? Log V2 is 100 liter and V1 is 10 liter. Okay. 10 liter to a volume of 100 liter. So initially we had V1 as 10 and finally the volume is increased to 100 liter because it is expansion, right? So it will expand. So if I cancel this, I will have log 10. Log 10 is equal to 1. Then by multiplying the entire value, we will get 28720.713 joule. Okay, this is the value. And if I take out this decimal and all, I will get minus 28721 joule as the work done for this reversible case. Okay. So the value of X is 28,721 joule. Clear? Direct substitution into the formula. Nothing to worry big. Okay. Shall we go for the next question? Are you all ready? Next, we will go ahead for NEET question. Okay. So this is all about the JEE mains. So mostly in JEE mains, you will get the question from thermodynamics in the numerical part. Okay, not from the multiple choice part. You will get the question from the numerical part. In all the questions that I have discussed till now, you might have noticed that none of the question has options, right? So they are asking this lesson question in the numerical part of the question paper. Okay. So shall we go for the NEET question? Shall we go for the NEET question? Okay, here is the question from NEET 2024 re-examination. Yeah. Choose the correct statement for the work done in the expansion and heat absorbed or released when 5 liters of an ideal gas at 10 atmospheric pressure isothermally expands into vacuum until volume is 15 liter. Which among the following is correct? We have to find out the correct statement for work done, expansion, and the heat absorbed or released when 5 liter of gas at 10 atmospheric pressure expands to 15 liter. And the condition is isothermal. What is meant by isothermal? Isothermal means temperature is constant. right? So temperature is constant means delta T will be equal to 0. Got it? If delta T is equal to 0, then from the relation delta U is equal to N CV delta T, if this delta T is equal to 0, 0 into anything will be 0. So delta U will also be 0. Got it? From first law of thermodynamics, we know that delta U is equal to Q plus W. If this delta U left hand side is equal to 0, then it means the right hand side is also 0, right? Right hand side is also 0. So Q is the heat, W is the work. So work then will be 0 and heat will also be 0. So which is the correct option? Which is the correct option? Very good, Rakshita. It is option C. It is option C. Got it? Clear? Now we will go for the next question. We will go ahead with the next question. For an endothermic reaction, choose the correct answer. What is meant by endothermic? Heat will be absorbed. Heat energy will be absorbed. Okay, so such type of process is called as endothermic process. Now tell me which among the following is correct. Heat is absorbed means heat exchange at constant pressure. That will be positive because it is absorbing the heat. If the heat is entering into the system, it will absorb. In that case, Q value will be positive. Yes, Q value will be positive. And for all endothermic reaction, delta H is also positive. Okay, delta H is also positive. Very good, very good. Option A is the correct answer. Exactly correct. Option A is the correct answer. Delta H is positive and Q is positive. Okay, if there is a system and if the heat is entering into the system, okay, then the Q value will be positive. If the heat is leaving the system, then the Q will be negative. Okay, so B and D are correct. Option A is the correct answer. Very good. Here is the next question. For the following reaction at 300 Kelvin, the enthalpy changes 15 kilojoule, then the internal energy changes. Enthalpy change means this is delta H. Okay. Internal energy change means we have to find out delta U. Okay. So again, if you find some question with delta H and delta U, you have to use this relation. Delta H is equal to delta U plus delta Ng RT. Okay. So since we are asked to find out delta U, so let me rearrange this. So it will be delta H minus delta Ng RT. Okay. Delta H is 15 kilojoule. So it is kilojoule means it is 10 to the power 3. So it will be 15,000 minus delta Ng. Number of moles of gaseous product, it is equal to 2 and the reactant is equal to 1 and 3. So it will be 4. So it will be minus 2. So delta Ng value is minus 2 and R value, we have to give the R value in terms of joules, right? So R value in terms of joules is 8.314. It is 8. Are you getting 19.98 as the answer? Yeah. It is 8.314 into 8.314 into temperature is 300 Kelvin given in the question. So the final answer will be, Rakshita, you have to give the answer in terms of joules. Okay. It is 19988.4 joule. So this is the value of delta U. Okay. So what you have given? Yeah, in terms of kilojoules you have said it is correct only. But we don't have the answer in terms of kilojoule in the options, right? So it should be option A, in which it is given in terms of joules. Clear? Shall we go for the next question? Yeah. The next question is from the entropy concept. So in which of the following process entropy increases? Can you guys try for it? In which of the following process entropy increases? What about in A? Will it increase or it will decrease? Entropy means randomness, right? Entropy is nothing but randomness. Entropy is nothing but randomness. So find out, when a liquid is getting converted to vapor, vapor means gas. What will happen? Entropy will increase, right? So in first case, entropy will increase because randomness will increase. In case of liquid, we have particles near to each other, but in case of gases, they will be very far. So in terms of gas, randomness is more. So the entropy is also more. Entropy is also more. Yes. What about in B? What about in B? Temperature is lowered from 130 to 0. Temperature is decreasing. If the temperature is getting decreased, so I have a system, okay, in which the gas molecules are there. If I decrease the temperature, what will happen? The molecular movement, the molecular motion will be less. The molecular motion, the movement of the molecule becomes less. Then what will happen? The randomness will be less. So entropy will also be less. So for the second case, entropy is less. If the temperature is decreased, entropy will also become less. Got it? In the third case, so here entropy is decreasing, so it cannot be the answer. In the third case, we have one solid molecule getting converted to one solid and two gas. So what is happening here? Number of the gaseous product increases. So if the number of particle increases, entropy will also increase. If the number of particle increases, entropy will also increase because the more number of particle will move here and there. So the randomness will increase and entropy will increase. Okay. So in the third case also, it is increasing. Coming to the fourth case, if you see, we have one chlorine molecule and in the product side, we have two chlorine atom. So again, the number of particle increases. Number of particle increases. So the randomness will increase and the entropy will also increase. Got it? So in A, C and D, that is option C. In all these three cases, the entropy is increasing. Okay, so you should know two things, two concepts from this question. One is entropy of the solid is less compared to the liquid, compared to the gas. So entropy of gas is more. Okay. If the temperature is decreasing, entropy will also decrease. This is the second thing. And one more thing is that if the number of particles increases in a reaction, entropy will also increase. So these are the three concepts you have to get from this question. Is this clear? Shall we go for the next? Shall we go for the next? Shall we go for the next question? Students? Yes. Here is a question. The work done during reversible isothermal expansion of 1 mole of hydrogen gas at 25 degrees Celsius from pressure of 20 atmosphere to 10 atmospheres. What we have to do? We have to find out the work done. Okay? For reversible process. work done for reversible process. Okay. And we are provided with the temperature and the pressure value. We don't have volume values, we have pressure values. So in terms of pressure, since pressure and volume are inversely proportional to each other, in place of V2 by V1, we have to put P1 by P2. Okay, in the formula. So what is the formula? It is minus nRT into ln of V2 by V1, right? So instead of that, you write P1 by P2. Got it? P1 by P2. So now you substitute. What is the number of mole? Number of mole is 1 mole. So it is 1. And what is the R value? It is 2. In terms of calorie per Kelvin per mole, it is 2. And what is the temperature? It is 25 degrees Celsius. Convert it into Kelvin. So it will be 25 plus 273.15. So it will be 298.15. It will be 298.15 into ln P1. So what is the value? Pressure 1 value, it is 20. And the final pressure is 10. So it is 20 divided by 10. So if I cancel this, I am having ln 2. ln 2 is equal to 0.693. ln 2 is equal to 0.693 and multiply with the remaining numbers. You will get the W work done for reversible processes minus 413.14 calorie. Okay. Minus 413.14 calorie. Option B as the correct answer. Clear? Yeah. Option B is the correct answer for this question. Clear? Shall we go ahead with one more question? So I'll go ahead with one more. Yeah, here is the question. Consider the following reaction and the delta HR naught is given for this reaction. What is the enthalpy change for decomposition of 1 mole of water? So what we have to find out? Enthalpy change. Delta H we have to find out. For the decomposition of water. Decomposition means you have to reverse this reaction. Decomposition means one molecule getting converted into 2 or more than 2, right? So reverse this reaction. 2H2O giving 2H2 plus O2. This is the decomposition. Okay, since I have reversed this, delta H will be equal to plus 483.64. Okay, since we have reversed, we have to change the sign. Now we have to find out the enthalpy change for decomposition of 1 mole of water. Here we have 2 moles of water. To find out for 1 mole of water, divide this by 2. Divide the equation by 2. So if you divide it, you will get H2O, 1 H2O, giving 1 H2 plus 1 by 2 moles of O2. So since we have divided this, delta H should also get divided by 2. So it will be plus 483.64 divided by 2. Okay. So the answer will be delta H is equal to plus 241.82 kilojoule. Okay. So option B is the correct answer for this question. Can you able to understand how to solve it? Any doubt? Do you have any doubt from this? Okay. So I think this is enough for today because it is already time. I hope this session is very useful for all of you who have watched this. Do you have any doubts from today's session, students?
No, ma'am.
Do you have any doubts from today's session? No? Okay. So thank you so much for listening to today's session. Meet you all with the next set of questions in the next class. Till then, take care. Bye. Okay. So I have